Hello, Math 8 students. This is Open Up Resources Unit 1, Lesson 4, Making the Moves. To get started, for your warm-up, we're going to do a quick reflection image draw. The clues are right here in reflection. So before we get started, I want you to stop and think, what are the things that you remember about reflections based on our previous lessons? What do you know about reflections? How do they behave? What information do we need for a reflection? Now that you've thought about that, here's how this works. I am going to flash an image on the screen for just 3 seconds. You need to look at that image, and then you need to draw what you remember. I'll give you 60 seconds of drawing time before I flash the image on the screen again for 3 seconds, followed by another 60 seconds of drawing time. And the whole goal is for you to be able to produce the image that I flash on the screen. Online users, you do have the advantage of trying to rewind or pause the video. No cheating. Just watch the video in real time. Watch for those 3 seconds, draw for 60. Watch for 3 seconds, draw for 60. Get ready to draw. I do want to point out that you also have the option to be drawing with your applet. It is a blank grid. It does have that triangle ABD, so you can use this blank grid to draw. But you can also print it off and draw directly on your paper. However you decide to do it, it'll show for 3 seconds. You'll be able to draw for 60. Get ready. Here's the image. "60 seconds of drawing time. See if you can reproduce that. Just continue to let the video play. We're counting down those 60 seconds. "30 seconds left before I flash the image on the screen again. "10 seconds. That's time. Now I'm going to show it for 3 more seconds again. Get ready. 60 more seconds of drawing time. Again, just let the video play out for 60 seconds while you draw. Just 15 seconds remain. That's time. Now let's compare your drawing to the original figure and see how you did. Again, this is what you started with. And here is the image that you should have drawn. Compare it to what you have on your paper or what you have in the applet. How did you do? Your strategy may have varied, but the one thing that would have made this the absolute most simple is identifying where that line of reflection is. Once you know where the line of reflection is, you can do the rest of it on your own without even seeing the image. Knowing that the line of reflection, that would be this mirror line, means once you have that drawn, you can simply know that B is staring straight into that mirror while the reflection is staring straight back the same distance away. And you could continue that with each one of those points. But at least getting started there, we would also know that this side, which is 1, 2, 3, 4, 5, 6, means that this side is going to be 1, 2, 3, 4, 5, 6. This side that was 1, 2, 3 means that this side is going to be 1, 2, 3. And all of that is made possible by understanding where that line of reflection is. So, as we continue to move on through this lesson, the point of this lesson is to help you understand how important the information is on these transformations. Depending on the type of transformation, we need certain pieces of information. We'll be going through this and trying to figure out what those pieces are and helping you practice using the terminology correctly and being precise in describing these transformations. What we're going to do now is you have this image on your paper, or in our next applet, we've got the applet that contains that same image. No matter what, we're all looking at the same image. I am going to describe a certain transformation. You need to listen to the transformation, take all of that information, and use what you can to reproduce the transformation I'm describing. No matter if you're using paper and writing it on the paper or using the applet, you're going to be creating what I describe. Are you ready? Let's get started. The first transformation that I want you to do is a reflection. Since we're doing a reflection, we need to know where the mirror or the line of reflection is. To find that line of reflection, find point C in your triangle. Move one step to the right from point C, and that mirror line, that line of reflection, is going to go up and down through that point. With that in mind, that means that C is standing one step from that mirror, so on the other side of that mirror is going to be step C again, but we'll call it C prime. Now observe that B is 5 steps away from the mirror. So take B, walk 5 steps towards the mirror, and know that B prime is going to be 5 steps away, but on the other side of that line of reflection. And similarly, for A is 2, 3, 4, 5, 6 steps away from the mirror, and A prime is going to be 6 steps away from the mirror, but on the other side. What does your image look like? I'm going to go to the next screen where you're going to see a series of images. The one that I described is right here. This one is the reflection. Hopefully it looks like this. In class, students had the opportunity to describe each one of these transformations, and we'll describe them now as well. The key pieces of information, if you had, I'm going to skip 1A, we're going to go to 2A. If you were trying to describe this to somebody else, you would have to include information that, first of all, it's a translation. That way the student who's listening knows that we are taking that figure and we're shifting it or sliding it, but we're not going to be twisting or spinning. And so a translation already helps us know what is going to be happening. But a translation, we need a little bit more information. We also need to know how much it's moving and what directions. So I would say we're going 1, 2, 3, 4, 5, 6, 7 units to the right and 2 units down. Since C is moving that much, B is also going to be moving 7 units to the right and 2 units down, and A is going to be moving 7 units right and 2 units down. When I described 1B to you, I started by letting you know that it was a reflection. And so that's when you remember that reflections are mirror images. You remember that a reflection flips over a line. So that already helped you understand what that image is going to look like. And now we can describe where the line of reflection is. That line of reflection, I told you, was 1 unit away from C, and it went straight up and down. Knowing that, you then could easily figure out that C is 1 step away, so C prime is 1 step away. B is 5 steps away, so B prime is 5 steps away on the other side. A is 6 steps away, so A prime is 6 steps away on the other side of that line of reflection. And 2B is the most challenging of all. Think about what is happening to this image How would we need to describe that? This is a rotation. And when we are describing a rotation, we need to know which point we're rotating around. Which point are we spinning around? I'll help you out with this one because it is rather difficult, but I want you to see that C is 2 steps away from our rotation point, so C prime is also 2 steps away. We talked about in the past how in rotations move about a circle, and so you can kind of envision what that circle would be like. B is also going to be moving around in a circle, but it will be its own circle, and this is going to be probably very poorly drawn. But you get the idea there. You can also see some other behaviors like how far away that is. That's over 1, 2, 3, 4, 5, 6, and 1. So 6 across and 1 up. And when we take a look here, we can see that it's actually 6 down and 1 across. So we're still seeing some of those same behaviors. Maybe A is angled just a little bit different. So identifying the rotation, understanding where the center of rotation is great to help us describe and know how these things are moving. We also need to know the degree of rotation or the angle of rotation. And we need to know the direction, counterclockwise, clockwise. This was a counterclockwise rotation of 90 degrees. Around this point. Let's move on. We now have these trapezoids on our isometric grid. This is another new applet. Which you see here. The first thing that I want you to do is practice how can we get figure A to move to figure B. There's a couple of different ways that we can do that. It's not just through a translation. See if you can explore other ways of getting there. So how can we move figure A to B, and then how can we move figure B to C? That's going to answer question 1. Question 2 says, what is one sequence of transformations that will take figure A all the way to C? You don't have to stop at B. How can you go from A to C? Pause the video to answer questions 1 and 2. You have the advantage of using the applet to help you figure that out. Play around with that applet. How can we move figure A to B, then B to C? Pause the video as you figure this out. I will demonstrate how we can do this in just a few minutes. Pause the video. All right, we're back. Hopefully you've been able to figure this out on your own. Here are some ways that you can do it. The easiest and most obvious is to do a translation. Remembering how to use our tools that are also explained in Canvas, I'm going to create the vector first. The vector is going to go from here to here because that's how I want this figure to move. Now that that vector has been created, I'm going to translate by vector, and I want to move this figure by this vector, and we can see that it moved there very nicely. So translation is the most easy and obvious. But I also would like to point out that there are other ways to do it. You can also do it by reflection. To get started, I'm going to add a reflection line right here. And now I'm going to reflect image A. So reflect image A over this line, and you can see it's in this position. Can you see it now? We can do it again. We're going to reflect this image over this line. Let me get another line in there. Again, reflect this image over this line, and now it landed perfectly on there. So although we can translate, there are other ways that we can get it there. I want you to be creative. Now, how can I go from B to C? Again, there are a variety of ways that you can do this. What I would do is I would take image B and I would rotate it around a point. So we're going to rotate image B around this point, and I'm going to go 60 degrees. And I know it's 60 degrees because remember, each one of these angles is 60 degrees, and I'm going to go in the clockwise direction. Now what is here? Now it's time to translate. I'm going to translate from here to here, so there's my vector. Now we're going to translate by vector this image by this amount, and it got it into position C. So we went from A to B, B to C. That would be your answer here. Exploring is good. I would still like it if you're taking notes to write down your response, write down the different ways that we can get there. And now it says, what is one sequence of transformations that takes figure A to figure C? So it's the same idea, but we're skipping B. We can skip B and go from A to C. And again, there's a variety of ways that you can do this. I'm going to reset my applet. One way that we can go from A to C is through a reflection. That might not be the most obvious way, but we can do it through a reflection and a translation. I'm going to move this point through using a vector to this point. So translate by vector. There we go. Can you see the reflection now? I can reflect on this line. And it landed right there on C. I like doing that because we didn't even need to use a rotation in order to accomplish that specific sequence of transformations. Which also gets us ready to the Are You Ready for More? Can we do it without a rotation? I just showed you how you could. Maybe the rotation is the most obvious way, but you can do it through no rotations by just reflecting instead. Can you do it with no reflections? And the answer is yes. We can also do it with no reflections because all I would have to do is take this image, rotate it 60 degrees clockwise, and now I can simply translate it so that it lands perfectly on C. So can we do it without any reflections? Yep, we can. We would just need to use rotations. The no translations one is more challenging. It is definitely possible, but it's not as easy or obvious right here in this applet. In order to move this into position C without doing any translations, you can do a series of reflections, as we already observed. Reflect, reflect, reflect. We can also do a rotation, and I'm not going to be perfect at this. This is not going to work exactly the way that I want it to. I'm going to say it's roughly here-ish, and I'm just estimating, so this is probably not going to work out perfectly. I'm going to rotate 60 degrees around this point. 60 degrees clockwise around that point. Oh, and you can see I'm off. I was close, but I wasn't quite there. So I'd have to reevaluate exactly how much I'm rotating. I need a new point. I need it to go a little bit further over. I'm going to guess there. I'm going to try it one more time. It's not going to be perfect, but I'm certainly trying. 60 degrees clockwise. Let's see how close I got. Ooh, I was closer. Looks like I need to move over a little bit more. I'm going to do this one more time because I'm so close to figuring it out. I want to get it there. Ooh, I lost my point though. Is it right here? We'll try right there. We're going to rotate this image 60 degrees about that point. See how close I got? I was closer the other time. So it's hard finding that exact point where we would be rotating it about. Ooh, I think I just figured it out. Last time, I promise. How about right here? I think this is it. This is money right here. Rotating this figure 60 degrees clockwise around that point. Got it. All right, figured it out. So we can do it with just one single rotation. It's kind of like, here's the trapezoid, here's my elbow, and I'm rotating around my elbow, versus rotating it around the fingertip and then having to move it into place. Thank you for humoring me as I worked through that. Hopefully you guys were able to have some fun with that as well. So can we do it using no rotations? Yes. No reflections? Yes. No translations? Yes. And now it's time for our summary. A move or a combination of moves is called a transformation. That is important. A move or combination of moves is called a transformation. When we do one or more moves in a row, we often call that a sequence of transformations. And to distinguish the original figure from its image, points in the image are sometimes labeled with the same letters as the original figure, but with the symbol attached. See that symbol? And so it would be, instead of A, which we pronounce A prime. A translation can be described by 2 points. This is so important, so important. A translation can be described by 2 points. However, I don't want us to focus on the 2 points. I'm going to keep on reading. If a translation moves A to A prime, it moves the entire figure that same distance and direction as the distance and direction from A to A prime. The distance and direction of a translation can be shown by an arrow. That arrow is called a vector. That's what I want to focus on. Not by the 2 points, but by the vector that shows how much those 2 points are different. A moves to A prime, and that vector shows that difference, that change. A rotation can be described. This is so important. A rotation is described by an angle and a center. So when we were describing rotations, we needed to figure out the center and we needed to figure out the angle. We also need to make sure we're saying the direction of the angle. It can be clockwise or counterclockwise. We can see this example here. Here's some fun facts here. Do you see how we have point P? That's our center. Do you see how we've connected point P to point B and point P to point B prime? Notice the angle that's formed. It's drawn in there. It's a right angle. But this is what's so beautiful. When I connect A to P and A prime to P, let me try that again. What do you notice? It's also a right angle because all of those points are rotated that same 90 degrees in this example. So each one is moving 90 degrees. That's exactly what it says here. And the last one, reflection. Again, this is so important. A reflection can be described by a line of reflection. We can sometimes think of it as a mirror, but I don't want us to call it a mirror. We can think of it as a mirror. I want us to call it a line of reflection or reflection line. Each point is reflected directly across the line so that it is just as far from the mirror line, but on the opposite side. So again, observe. A is half of that diagonal away. So A prime is half of that diagonal away. B is a diagonal and a half away. So B prime is a diagonal and half away. Each one of these points has its image on the other side, the same distance away. And our 2 new glossary terms, sequence of transformations and transformation, which we highlighted up above. Now it's time for our cool down. What does it take? Here we have triangle ABC. It's just a random triangle. It almost doesn't even really matter for the problem. The questions that we have are, if we're going to describe a translation of this triangle, what information do you need to include in your description? Next question. If you were to describe a rotation of triangle ABC, if I want you to rotate this, what do you need to include? How do you need to describe that so that I rotate it correctly? Final question. If you were to describe a reflection of triangle ABC, what information do you need? How would you communicate that to me? If you're stuck on these questions, please review your summary page where we just highlighted everything that I said is so important. All of the answers are right there. So pause the video, cool down, answer these questions, and check your own understanding. We'll come back together in a few seconds when you're ready. All right, let's go over this. If I'm describing a translation of triangle ABC, the information that I need to include is the direction and distance of the translation. In other words, that would be the direction, up, down, left, right, and the distance, that refers to the magnitude. We've talked about this. Direction and magnitude, that's our vector. If we're describing a rotation of triangle ABC, we need the center of rotation, we need the angle of rotation, that would be our degrees, which also includes the direction. Are we going clockwise? Are we going counterclockwise? And finally, if we're going to describe a reflection, we need to know where that line of reflection is. Once we know the line of reflection, we already know that the reflection is going to be the same distance but on the opposite side. So once we know the line of reflection, we know everything else that we need to know. Again, that means we need to know where is that mirror, which we're calling the line of reflection. That's it for today. Your practice problems are in Canvas. For this particular homework assignment, I think we can probably get away. Nope, it can't be done in Canvas. This is another one. Print it off, do them on paper, and then take a picture of what you have done on paper. Submit the photograph showing these practice problems completed. As usual, let me know if you have any questions. You can reach me through email, and we'll see you soon. Have a great day.